Hello, hello. Yep. Okay, so we are now live and we will be solving, I think, problems from cses today. So, uh, let's see. Let me make the separation here. Sorry. Okay. So I will solve the problem here. And the problem is and the problem is this problem. I think we tried to solve this and the answer was not correct. What I did. Okay, so this is not going to work anyway. Okay, so I've researched some things about this problem and okay, so 10. What is the input? 20, 15, 17, 35. 20, 15, 17, 35, 25, 40, 12, 19, 13, 12, I think. And we will add 0, 20, 15, 17, 35, 25, 40, 12, 19, 13 and 12. Okay, so we need this. How do I can I okay, diagram, image, image. I don't think I can. Okay, image. Where do I upload? Uh, it is not letting me upload. Okay, upload. My device. Okay, we are set. So this is the test case given to us. Okay. Okay, this is the mountain range. And when solving this question, the first thing that comes to mind is we can try to solve this in n square. Okay, how basically we will start from the top, the highest mountain, or for that matter any mountain, and we will iterate and see if this mountain can reach okay. So the simplest solution in n square is basically you start from here. Okay, you start here and then you iterate in this direction or any direction, basically here only, but you will need to go back also if you are here, so you need to iterate both ways. It's from here to here and then here to here, and for each mountain you will check whether it is possible to move to here from the current mountain, and you will also set basically what is the highest mountain you have encountered in the way. Okay, so if you are starting from 40, then you will go here, go here. Okay, 25. So yes, it is possible because 40 is greater, and the maximum you encountered till now is 40 only. And when you go to 35, this will be set to this will be set to what? This will be set to okay. So if you can go from here to here, so yes, that is possible. If you go here, then yes, it is also possible to go, because 35 is less than 40. 17 is also possible, 15 is also possible, 20 is also possible. And if we go for 35, for 35, it is possible to go to 25, it is possible to go to 17, it is possible to go to 15, it is possible to go to 20, but it is not possible to go to 40 because it is higher. Okay, so we will stop the iteration here. Similar for all this, and for each iteration we can store, we can have a dp state, like dpi. We can have dpi, which is basically the maximum number of mountains visited. uh, okay, so mountains visited, uh, starting from ith mountain. Okay, maximum number of mountains visited starting from ith mountain. That is done. So we started from 40. Okay, so in this case, or if not this, then we can also try to do it in reverse, but let me explain what the approach is basically for n square, or for that matter anything. So basically, if we are at the ith mountain, then what we can do is we can check in the left and right, this part and this part, which is the maximum height mountain. Okay, and whatever, or we can check for the mountains both in both direction, such that it does not violate the conditions, right? For example, from 40, you would want to go to 35 or 25 or any other, but from 25 would not want to go to 17 because 35 is in between, right? So you can run a loop so that you skip past that, and in doing so you will calculate two values, right? One is for the left and for right. Okay, basically you will calculate two indexes. You will get two indexes, or wait a second, we are doing it n square, right? So in n square we can just brute force it. I mean, we can check all the mountains, of course, aside from the condition, mountains that violate the condition. So we can start from 40. We can check all these. Okay, and again, if we start from 35, we can go to all these, and we can go here, but we cannot go here, so we will not be checking these. And similar to that, for 25, we cannot go here, we cannot go here. So the only mountains you can visit is 25 only, so it will be 1. Okay, and Yeah, so if we are doing that, then I think we should because it will be a problem if we are doing that, then we need to start solving from the lowest mountain, right? Otherwise we won't be able to add up to the 40. So we will sort it, and okay, so if we are doing that, then there is no point in doing an n-square solution. Hmm. Or is there, if we start from 20 and then go to 15, 17, 35, or any other amount, we cannot go to 25, so there is that. Okay, so 0 is basically our base case. That means that and 0 index, it is the mountain range is 0. It is not a base case basically, but yeah, it is there for calculation purposes only. We are doing it in one index based. Okay, how do I do it in n square? I'm sure it is possible to do it in n square. Oh, okay. We can do it in a way that okay. So for each mountain, what do we want? We want to go to the next highest mountain in both the direction, right? We want to go to the next highest mountain, and so how do we do that? Basically, we'll run a loop from the 0 to I minus 1th position and I plus 1 to the last nth position, and we'll find the greatest height mountain. Okay, and for this mountain we will add that value, or what we can do is we can add, if it is 1 now currently, because single mountain, the answer will always be 1. Why? Because if there is no mountain in left and right, then only mountain velocity is 1 only, so base case for one mountain will be 1 only. But here our dp, okay, initially it will be 0 only, so we will push it to other state. Okay, so from 1 it will go to here, so it will become 2 here, and it will also become 2 here, and from 2 we will also check in the left what is the maximum and in the right what is the maximum. Okay, of course not exceeding the value itself, so 40 will not be possible, so we can go here, we will be able to go here, and we will be able to go 20. Okay, similar here, 19 will be able to go to here, also this will be able to go to here, this will be able to go here, and then the only possible way for it to go here, so it will be 4, and here it can go 17, it will be 4, and then it will go to 5. So starting from the maximum element we can get the answer like this. Okay, but yeah, starting from the maximum element we can go to the answer like this. But how do we calculate the next left maximum or right maximum? That we can do using stack, or even using just loop only. So yeah, that definitely will take an n-square approach. That will definitely be an n-square approach. So what we are doing here will be a little different. The concept will be same only. We will be calculating dpi by getting the left maximum and right maximum only, and then adding it to and adding 1 to it. That will be the transition. Okay, but this will be a little different. So what we will do is we will sort these first. Okay, so we will do it like this. 12, 12, 13, 15, 17, 19, 20, 25, 35, 40. Okay, we will sort it like this. Let me upload it. Okay, so we will sort it. Okay, let me check the values are correct. Okay, values are correct. So we will sort it, and then we will start from 12. Okay, we will maintain maybe set or something like that. We will maintain a set. So we will start from 12. We will check what is the lowest in the left that we can go, what is the lowest in the right that we can go, not from here but from this set. So since set is empty initially, so there will not be anything in the left nor right, so it will return 0 only. So dp for this element, for let's say it will have an index, not this index but maybe this or this, anyone. So let's say the lowest one or anything, we cannot go to anywhere, so it will be 7, let's say, and it is 10. I'm writing the original index here. For 13 it is 9, for 15 it is 2, 17 it is 3, 19 it is like what, 8, for 20 it is 1, 25 it is 5, I think, this it is 4, and it is 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the indexes. So dp of this value will be maximum of left and right both is 0. I'm storing it like this. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. It will be 1. Okay, and then we will go to here also we can see the same thing happening, so it will be 1 only. Now when we are at 3, at this point in time, when we are at 3, at this point in time, we will have some values in the set. Okay, we will have some values in the set. And what values? It will be so both of these values will be in the set at this time. 7 and 10, and since we are doing it in a sorted manner, so we know that whatever it is in set is always always less than the current value. Okay, so for 13 what we'll do, we will do a we cannot do a left check, right? Because if we do a left check, then that means we are able to go to a value which we are not supposed to go, but I don't think it matters. Okay, so both of these values are 1 only, and for 13 we can go to left. For basically in this only we will do lower bounds for both. We will do lower bound and we will do upper bound. Okay, so lower bound 9 will give me 7, so dp of 7, and upper bound 9 will give me 10, so dp of 10, maximum of which will be 1 only, and I'll add 1 to it, so 13 dp will be 2. Okay, dp 13 will be 2. Now I'm at 15. Now from 15, is it possible to go to 13? Can I go to 13 from 15? Okay, I see. So that is the issue with the that is the issue with working as sorted in ascending order, right? Suppose we have done it, we would have done it in reverse order, like this: 35, then you have 25, you have 20, you have 19, you have 17, you have 15, you have 13, you have 12, you have 12. Okay. Okay, suppose this was not the dp state, but rather this was the dp state. Ending at. So how will we transition from it? So it will be same, but the idea will be a little different. So basically we will check for each mountain what is the rightmost what is the highest mountain in left, what is the highest mountain in right, and we can go to any one of them, and whatever gives me the maximum value I'll consider that and go there. Or basically again one can reach me from there. Okay, so it is that only. So we will do it in this order. So if we start, we'll process it in reverse sorted order. So if we start from 40, so currently in this set I have no one. Okay, currently in this set there is no one, so it is empty. In both left and right I will get nothing, so it will be maximum of 0 and 0 1, so it will be 1 only. Okay, so for 40, which is 6, so 1 2 3 4 5 6, it will be 1 only. Now for 35, at this time 6 is all there in the our 6 is there in our set. So for 35, in left side there is no one. Okay, because basically lower bound 2 there is nothing, but upper bound 2 there is 6. So maximum of both is 1 only, and 1 plus 1 will be 2. So 4 this will become 2, and we will put 4 in here as well. Now for 25, 3 for 3 not 3, for 25 is 5. What is the upper bound, what is the lower bound? What is the upper bound, what is the lower bound? Both are present here. So it will be 1 and 2, maximum of which is 2 plus 1, so it will be 3. So 25 will be 3, and it makes sense because if you see the maximum number of mountains that you can reach ending at 25 is 3 only, because 1, 2 and 3 hops we can reach 25, or basically 3 mountain visits we can reach 25. So that makes sense. So yep. Now next one is 20, and for 20 is at 1. So for 1 there is no lower bound present, so it will be 0 from that side. For upper bound we have 4, and that gives us 2, so 2 plus 1 3, so it will be 3. Now similar to that we have 19. For 19 which is situated at 8, the lower bound is 40, basically 6, and that is giving us 1, and the rightmost bound is nothing, so it will be 2 only. So for in case of 19 it will be 2 only. Now I'm done with this, I'm done with this, I am 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 done with this. No, I am at this. For 17 again, 17 is at 3, lower bound is 20, upper bound is 35, so 1 and 4. Maximum of 1 and 4 is 1 and 4, maximum is 3, and 3 plus 1 is 4, so it is 4. Similarly, now I'm processing 15. For 15 we have in the right 17, left 20, and for 17 it is 4, 3, maximum will be 5. Okay, maximum will be 5. Now we'll go to 13. For 13, in the left 19 is there, in the right no one is there, so it will be 3. Now the tricky part. So now we arrive at 12. Okay, now we arrive at 12. So for 12, what is the upper bound, what is the lower bound? It depends on which 12 are we processing. So if we are processing this 12, so it is 10. It is 6, 4, 5, 1, 8, 3, 2, 9, 10, 7. Okay, if it is this, so whether if we are processing 10, that means we are doing what? If we are processing 10, what were we processing? We are processing this 10th number. So we are here, and for this 10, so this one, in the left we have 3, giving us 3, and the right we have nothing, so it will be 4. Okay, and for the other 12, we will check what is in the right. So for 7 we can get 8. Okay, that is okay. And for the left, from the left we will get 6. Yes, 6. But should we push the other 12? Because if we push it, then the upper bound or lower bound results may not be be what so but we are if we are doing it with index, then I don't think there should be any problem. We are doing it with index, but that is the thing now. If there is a case such that 2 12s are consecutive and we have like this, then if we process this first or maybe this first and put it into the set, then for this guy a lower bound will give me this again, this guy, but it is not allowed, right? So yes, we will not put similar one in the set, or Okay, so we need to have something that will prevent us from adding uh, a valid index which is not valid in height. Basically, yeah, the transition is not valid, but the index itself is valid. So we have to avoid inserting it into here until we process this. We won't be pushing it here. So if we can have a last height something variable, and that variable will be uh, just a second. Okay, okay, okay. So yeah, we will be keeping a variable last height something, and we will check whether the current height that we are processing is not equal to the last height. Then only we will input. We will put the. Then only we will put the value in the, you know, set. Otherwise, we don't need to, but still we need to have them stored somewhere. So all the equal indexes we need to have them as well, right? Because we cannot let them we cannot process them at the same time, but we need them for processing other mountains. So we will have a buffer type of thing. Okay, so that this will work out, and the answer will be simple. It is nothing but the maximum of dp. Okay, so let's go and implement it. Stream 28. We are getting n, so we are getting n in the input. We are getting height, so height I need to have position right, so instead of doing this VPII mountains, and this is of size n. I'll take input mountains. One index. Okay, this is done. We'll sort it. How will we sort it? We'll just reverse sort it. It's also done. We will have a set of what integer. Set of integer, which will basically give me the left and right, both. So processed, so E mountain, I think M is sufficient. So P is there. I need also a buffer, so buffer, and also I need a last height. I will set it to, since we are doing maximum first, so I'll set it to the maximum here. Now let's go to so we will have an height. Height is basically the first value. We also have the index, which is basically the second value, and we'll also check if the last height is, if it is not equal to the height, then in that case we'll do something. Otherwise we'll calculate the L, which is this processed mountains, the processed mountains, and I'll do lower bound for the index. The right also will do upper bound for index. That is done. So this may give me null, not this is, this should be this set. And then I'll have a left value which will check if the lower bound can be the starting value. What does lower bound return? Lower bound CPP. If it could not find anything, beginning of the range. Okay, so if I do lower bound and I get I need to check if it is equal to the beginning. Okay, that means all the values are greater. Okay, then I'll check if all the index are greater, then that means there is nothing in the, okay, we are in the left, there is nothing. Otherwise it is basically this. If not, we will check if f star LP is greater than the IDX. If this is the case, then of course it will be 0 only. Why am I doing this? Because I am not sure. The thing is, the beginning of the set is equal to the first element, right? This is the beginning of the range, so it will be the first is I'll add a buffer. Hmm. Okay, so the thing is this thing left for left. If we are doing lower bound, okay, if we are doing a lower bound, this this thing should also be this thing can be lower bound because we're not uh, entering the current index into set before it's processing, so there is no issue in that. But this one here, lower bound can cause problems because if if all is greater than then this beginning of the range now, so it is giving me the next greater element. Next. Okay, so what does it mean when it is given p dot end? It means that all the element are greater than idx. Otherwise it will give that element, or if all the element are less than the idx, then it will give the beginning of it. So if we have processed 1, 2 and 3 index, and now we are processing 6th index, then ideally I'm not going to think much about it. And we'll just do dpi is equal to maximum of dpl dp r plus 1. Save, and the answer is basically the maximum out of all the values in dp, and we'll print that. Okay, I'm done. Okay, we don't have a dp. Okay, answer is 4. 25 is not getting updated properly. Why? Think it's because of this. Maybe there is an issue with set. Or maybe we can have two sets. One storing elements in reverse order, the other is okay. So this will store indexes in this format. This will store it in this format. Okay. Let's see. We'll insert in both. But we'll calculate from here. Why is this 5? Okay, okay. That's the answer, that is 5. Okay. We will submit it. Done. Okay, we are done. So that was it for today's stream. We took 1.5 hours to solve one problem. Bro. And that was not even a hard problem. We have solved harder problems than that within an hour. Okay, so that's it for today, and I'll see you guys tomorrow. Till then, stay healthy and sleep well, and